Good morning friends. So today we will be seeing a question from Leetcode, that is 4 divisor. The current question that is given to us, we will be given an integer num array and we need to return the sum of the divisors of an integer in an array that have exactly 4 divisors. Now divisors we all know, like multiplying the numbers from which we can form a number. Like 21 has 1, 3, 7, 21. Like this we can have numbers. Now what we need to do, we need to return the numbers, or we need to return the sum of the divisors which have exactly 4 divisors. This is the question. The question is pretty straightforward. A number with 4 divisors, exactly 4 divisors, we need to sum all the divisors and return the number. And we need to do it for every array, every element in the array, and return the sum of all the sums. I hope the question is clear to you all. Now let's just see or move toward the theory part or the explanation part. So we have an array like 21, 4 and 7. Now leave about the array. Let's just see how we can find the exact number that we want to have and then calculate the sum of it. Now if you see, let's just take an example of 21. 21 has 4 divisors, 1, 3, 7, 21. These two numbers will always be there if it is not 1. Obviously, we will be having 1 or 2. If it is 2, we will be having 1 and 3. We will be having 4, 1 and 4. So now we need to only check if a number has only 2 different divisors other than these two numbers. We need to check if the number only has 2 divisors, except then 1 and 21. Now how we can check this? Let's just see. How we can check if a number has only 2 divisors. Now let's take an example of 8. 8 has 1, 2, 4 and 8. Only 4 divisors. Now if I talk about 27. 1, 3, 9 and 27. Only 4 divisors. Now after multiple observation and divisibility, you can think about a number which is a cube of any prime number. I will tell you why I am telling prime number. If a number is a cube of any prime number, then it will only have 4 divisors. Like 8 is a prime number of 2, 27 is a prime number of 3. Let's take the 4, 4, 16, 16, 4. It will be having 1, 4, 16 and the number. I don't know the number. 16 into 4, the number will be this 16 into 4. Like, but now you can see 4 is not a prime number. 2 and 3 was prime number, 4 is not a prime number. Are these only divisors of 4? No. There is only also 2 exists, there also 8 exists. Now why I said prime numbers? Because if I do one number, the second number will be the square, like the x square or the prime number square. This number is not divisible by any number. So this can not have another multiple factors, while 16 can have 8, 2, 4. So that creates more than 4. If I have 8, let's suppose 5 is a prime number. The 5 has 125. Now 125 can be created by 1, 5, 25 and 125. This. Now why 5? Why prime number? Because this prime number cannot be divisible by any number else. This prime number also cannot be divisible by only 5 and 5 because it is a prime number square. So it cannot make more than 4 divisible. Rather than when we talk about 16, when we talk about 4, 4 also have 1 and 2 and 16 also have 8, 2, 4 as their divisible. So the divisible will always be greater than 4. So if you have a prime number cube, it will always be less. It will be having an exactly 4 divisible. I hope this first thing is clear to you. The first check I can do is if my number is cube of prime number. If it is a cube of prime number, then it will be my answer. It will be my number. How will I do the sum? 1 p into p plus p into p into p, or the n number, you can say. These are the square, like cube root of n. So this is my first condition. Now we see 21. Is 21 a prime number? Cube of prime number? No. Then I need to check for this. Now let's just check for 21. Now for 21, the first brute force solution that you can have, count all the divisors. Count all the divisors and then check if it is count is equal to 4. Then do the sum. First thing, the brute force solution can be this. But we will not go to the brute force solution. Now we know the divisors. For calculating the divisors, what we can have, I know 1 and 21 will always be there. So I need to care about between 1 and 21. So I can start my number with 2 and end with n minus 1. First thing. Now if we have studied maths, we know the divisor always come in pair. Divisors always come in pair unless and until it is a square of some numbers. Unless and until it is a square or something, the divisors always come in pair. If it is a square, let's suppose 4, the divisor is 1, 2 and 3 because 2 square is this. So if it is not a square, divisor always be in pair. So I do not need to check half, I do not need to check full. I can go to under root of n, or you can say under root of 21 rather than going towards all the number. And now what I can do, or what I will check for this, then divide the number by the number I which I get and check if it is divisible. The n divided by I. So I will be getting two different numbers. If the number is same, then the number is square, so we can reject it. Either we can do our maths. Now let's suppose we got two different numbers. Let's suppose we got 4 and 2 and 4 for, let's suppose, finding a divisor of 8. We need to check if these numbers are prime or not. Why prime? I just told you, if it is 16, it is not prime. That means it will be having more divisors of its own. Will be contributing in the divisor of the number that we have. So 4 will be contributing to 1, 4. This will be contributing more. So what we need to check? We need to check if the number has different divisor. Okay, 8 is, I guess, wrong because 8 is a cube of 2, so it will be working fine and it will be satisfying the first condition. The first condition, and it will not be going in the loop. Let's just take another. Let's just take not 16. let's just take 20. So 20 has 1, 20. The first number we will find is 2, and then the dividing by 20 by 2 will be 10. Now 10 again has 1, 5 and 10. 2, 5 and 10. 2 is already present. 5 will again contributing in the divisor of 20, that thus not making it limited to 4. So what we need to check, these two numbers should be prime. If they are prime, I will have 4 divisor. In the case of 21, 1, 2, 1, 3, 7 and 21. 7 and 3 both are prime number. So I do not need to check that if there is more divisor or not. This will be my answer. Because if the divisor is prime number, there is no another divisor that can exist. You can do it for anything, like let's just do it for 21. Let's just do it for 6. A small number. 1, 6. Now the first number divisor 2. 2 divided by 6, 3. Both are prime number. There cannot exist any number. There cannot exist more than 4 divisors. Similarly, we can do it for, let's suppose, 18, let's suppose. Just a random number. 1, 2. From 2 we got 9. Now 9 is not a prime number, so we have 3 also a divisor. 6 also a divisor. So that cannot work. I hope the explanation is a little bit clear to you, like the approach we can have. The first check we need to have it if it is a prime number cube. If it is not the prime number cube, then we can go towards checking if the divisors are prime or not. If the divisors are prime, then we can say the number is has only 4 divisors and we can return the sum of the number. I hope the explanation is clear. Okay, let's move towards the code. So first, normal you can Google it, you know how to make check prime number. Now what I will be doing, I will be checking if the number is cube root of any number. If the number is cube root and the number is prime, then I can just return 1 plus p, the number, the square root, the square and the cube. If not, I will be checking the number divisors. If the divisors are prime, then I will be returning the answer. Either I will be returning -1 in both the scenarios. I will be checking for every number and returning the result. I hope the code is very simple. Let's just try to run the code. Okay, we got all test case approved or accepted. Let's just submit the solution. Okay, now we got a successfully submitted answer. So this was today's question, that is 4 divisors. If you have any doubt regarding the question or regarding the explanation, you can drop it in the comment section, or if you have any better approach, any another approach, you can feel free to write it in the comment section. Thank you.